Hey, what's up, guys? This is Mr. Myesis here, and I'm going to talk to you about type 1 error. And actually, I'm going to talk about a little bit about type 1 and type 2 error just to kind of describe them. But in another video, I'll really talk about type 2 error and power. I got the power, right? What is it in terms of statistics? What do we use it for? So let's take, we're going to talk right here. I'm going to talk about type, oh, goodness gracious, what was that? I'm going to talk about type 1 error in this video. So let's first talk about, let's get a scenario here. Let's get some context going. Suppose that I did a hypothesis test and I conducted the hypothesis test and I want to see, hey, what's the proportion? Let me check to see if the proportion of students in my school or in a school is greater than 50%. So the majority they enjoy statistics. So I do my study. I collect a random sample of students and I get a p-value of 0.02. And now me as a researcher, 0.02 is a small enough p-value that I can go and say, you know what, there is sufficient evidence that the proportion of students was greater than 50% who enjoy statistics, like me. All right, let me just quickly write my hypotheses. So my null hypothesis is going to be p is equal to 0.50. And my alternative hypothesis is going to be that p is greater than 0.50. So I'm going to have a one-tail test, a one-tail upper tail test, right? And my one-tail upper tail test, where p is the proportion of students who enjoy statistics at the school. All right. And I do my my test and I get my p-value of that. And so now remember that I'm taking a sample of the population and I'm trying to decide what is all the population doing given the evidence that I have in my sample. So here are the things that could happen. I could, right? These are the possibilities that could happen, right? In reality, this is in reality. What's going on in reality? Well, in reality, I can reject the null, which in this example I did. I rejected the null hypothesis when it really is false. So let's say in reality, it actually is false, that it's 50%, and then I rejected it. That's good. Great job, Mr. Myesis. You are right. Woohoo! I'm right. Okay. Well, the second outcome could be that I reject the null, but really the null was true. That there was in fact 50% that like stats, but I had evidence that there were more. So I rejected the null when really it was true. I made a mistake. Something occurred. That is called a type 1 error. Okay, so oops, my bad, type 1 error. Type 1 error. So that's what a type 1 error is. Now this type of error is not the same type of error as we talked about before with the standard errors, like a standard deviation. This is actually an error, a mistake, okay? And I'll show you exactly well, I won't show you exactly, but I'll show you kind of how it deals with the probability. So another outcome would be that we fail to reject the null when the null really is false. If I failed to reject the null, but the null was false, I made another mistake. Oops. My bad again. Uh-oh. This is called a type 2 error. All right. I could also fail to reject the null when the null in fact is true. Good job again, right? I did the right thing. The null was true and I failed to reject it. Good job. So just a side note before I get back to type 1 error and we talk a little bit more about type 1 error. We need to understand which one's which and just remember that for the AP exam if you're taking AP statistics. And the way that I think is one way to understand it is, or to remember, is that you can just remember the type 2 error. Now we don't write 2 is like that. We write it as a Roman numeral 2. But type 2 is fail to reject. Okay, so we failed to reject. We fail to reject the null when it's false. Okay, we fail to reject a false null. That's how you remember the type 2. And then you remember that we reject, which is only one word before the null, right? We reject the null when it really is true, is type 1 error. So let's talk about type 1 error just a little bit more. Let me go back to my scenario here of the, actually, let me go this, one more thing before I go back to this scenario. Let's say I did my hypothesis test and I have my normal model, okay? At some threshold around here, so one-tail test, remember, at some threshold on this side of the threshold, I'm going to reject the null. And on this side of the threshold, I'm going to fail to reject the null. And if my p-value is over here, if my p-value is some shaded region over here, then I'm going to reject the null. But if my p-value is shaded over on this side of whatever this threshold is, then on this side of the threshold, then I'm going to fail to reject the null. If you remember from previous videos what that threshold is called, that's called my alpha level. Right? So if the p-value is lower than alpha level, I reject the null. If the p-value is higher than the alpha level, then I fail to reject the null. So the p-value, this alpha level, all of this part, this alpha level is really, it's the probability of rejecting the null hypothesis, right? The probability that I reject the null hypothesis is going to be alpha. Well, let's suppose we did a type 1 error. Type 1 error. This normal model tells me that the null hypothesis is true. The null hypothesis is true. What we should have done? What should we do? We should fail to reject that, but instead we ended up rejecting the null hypothesis. So what's the probability that we end up rejecting a true null hypothesis by accident? In essence, what is the probability that we commit a type 1 error? That probability is alpha. Okay, so the probability of a type 1 error is alpha. And just to note, like, we get to choose alpha. We could say alpha is 0.01. We could say alpha is 0.005. There's no real way of you know, there's no mathematical way of making alpha. We just choose alpha, whatever is appropriate for our problem. The problem here is, though, that if alpha increases, then you're increase, like if you make alpha bigger, then you're going to increase the probability that you get a type 1 error. But if you make alpha smaller, like if you move alpha way out here, then yeah, you're going to make your probability of committing a type 1 error smaller. But that also means it's harder to reject a null hypothesis, which means if the null hypothesis was in fact false and it's hard to reject it, you're going to end up making a type 2 error more often. So the type 1 error and type 2 errors kind of have an inverse relationship. The higher your type 1 error, the lower your type 2 error. The higher your type 2 error, the lower your type 1 error. So that's an important distinction to make when we get to it. And I'll probably go over that a little bit in the next video. Let's go back to my context, because really in statistics, you're going to be, with type 1 and type 2 error, you're going to really be looking at context. So what is the context in which I would make a type 1 error for this problem that I talked about with the percentage of students that enjoy statistics. Well, a type 1 error would be if I rejected the null hypothesis, which in fact I did. So if I rejected the null hypothesis and I said, you know what, there is evidence that the proportion of students was greater than 50. Well, 2 weeks later, the administration actually was able to do a census, got every single student that was there, and they found that 49% of all students enjoyed statistics. So what happened? Well, in reality, by the census, I should have failed to reject the null hypothesis, but I didn't. I did a type 1 error when I rejected the null, and I said, look, there's evidence that the students enjoy statistics, when in reality, they don't. Well, the majority do not. So how could this affect, what effect would this have on like the actual, reality and what's going on? Well, maybe since I did my study, and I think, oh, okay, well, there's evidence. I see there's evidence that the proportion of students, really like statistics. Must mean we're doing a great job teaching them statistics. They really enjoy it. We'll continue to do the things that we're doing. When in reality, we missed a really good opportunity. What we really should be doing is we really should be refining and making it more enjoyable, because in reality, they don't actually really enjoy statistics. Although I think if you were in my class, you would really enjoy statistics, because, I think that percentage is pretty high for me. Anyway, again, a type 1 error is when we have rejected the null when in fact the null were true. And this happens, it's possible that it happens in our statistics and our hypothesis tests. And I think really what you need to know is, when you do this in your AP class, if you're doing this AP, or your teacher is going to really ask you in context, what does that type 1 error mean in context, and what's the consequence of that happening in reality? Do we miss out on an opportunity to do something because we've decided a different, we've come up with a different conclusion based on our hypothesis test? And these actually occur in real life situations. It really occur in business, all the time. So that's type 1 error. In another video, I'll talk about type 2 error and power. All right. See you guys later.